You know, when we look out into the dark, it's so easy to think of space as just this random, lonely, empty void. But actually, the truth is so much more magnificent than that. Welcome to The Explainer. Today we are diving into literally one of the most phenomenal construction projects in existence. We're going to look at how gravity acts as this master architect, single-handedly building the vast, glowing metropolises that we call cosmic cities.
Okay, so let's dive right into this. There's this really beautiful way to think about the universe. Galaxies are the great cities of the cosmos. Think about it. When the universe was super young, the very first stars were incredibly lonely. I mean, they were just these isolated little points of light sitting in an ever-expanding darkness. But they didn't stay that way. They didn't just float aimlessly forever. Instead, they actually began to gather together. They migrated, they clustered, and they built these massive, bustling cosmic settlements that eventually became the fundamental building blocks of the entire visible universe. But it makes you wonder, right? How did that actually happen? Who or what was the architect here?
Well, there is an incredible irony when it comes to gravity. On small scales, like down at the quantum level, gravity is actually the absolute weakest of the four fundamental forces of nature. It's incredibly feeble up close. But stretch it across cosmic distances, and suddenly gravity becomes the dominant master architect of the universe. In the very early universe, there were these tiny, almost imperceptible density variations, just little clumps of matter here and there. And gravity? It seized upon those tiny imperfections. It grabbed hold of them and just relentlessly used them to pull in more and more matter, slowly building the foundation for literally everything we see today.
And the sheer scale of this gravitational pull, it is almost impossible for our human brains to really comprehend. We are talking about billions. Gravity didn't just casually pull a few stars together into a quaint little neighborhood. No. With just relentless patience, it scooped up colossal amounts of raw gas and dust, wrangling millions and eventually billions of isolated suns into enormous swirling clouds. To put that into perspective for you, our own galaxy contains somewhere between 100 and 400 billion stars, hundreds of billions, and they are all bound together by this one single persistent force.
Now, as you can probably guess, this monumental construction project definitely didn't happen overnight. Following the rapid expansion of the Big Bang, it took several hundred million years for the earliest galactic settlements to even emerge. And these weren't the beautiful, elegant pinwheel structures that we're so familiar with today. No, they were small, messy, and completely chaotic. But they were absolutely crucial. Why? Because they marked the universe's very first transition into possessing real structure. Then, over the next several billion years, gravity just patiently sculpted those chaotic clouds into the highly organized, structured forms we recognize today.
And the end result of all that sculpting falls into three distinct cosmic architectural styles. First up, we have the spirals. These feature those graceful, sweeping, rotating arms. And fun fact, our very own Milky Way is a specific type of this called a barred spiral. Next are the ellipticals. These are massive, almost egg-shaped collections totally dominated by older, mature stars, and they often lack the dust needed to make new ones. And finally, we have the irregulars. These guys lack a defined shape entirely, which really reflects a violent, turbulent history heavily shaped by cosmic collisions and gravitational mergers.
But here is where the story takes a rather unexpected, almost haunting turn. What invisible force actually holds these massive cities together? Because when astronomers started crunching the numbers, calculating the mass of all the visible stars in the swirling gas, the math simply didn't work out. It just didn't add up. There just wasn't enough visible stuff there to generate the gravity needed to keep these rapidly spinning galaxies intact. By all known laws of physics based on what we can actually see, these cosmic cities should literally be flying apart, just scattering their billions of stars out into the dark void. So, what on earth is the missing piece?
The answer? Dark matter. This is the hidden infrastructure of our cosmic cities. It's this entirely unseen component that provides the vast majority of the gravitational framework necessary for galaxies to form and, more importantly, to remain stable. It is totally invisible. It doesn't interact with light at all, but astronomers know for a fact it's there because they can measure its massive gravitational footprint. In fact, it actually outweighs visible matter by roughly 5 to 1. It is literally the invisible scaffolding that gravity uses to hold billions of stars in their delicate, swirling balance.
Now, just because they are held together tightly doesn't mean they just sit perfectly still, not at all. These cosmic cities undergo some extreme urban renewal. Galaxies are constantly moving, and eventually their paths cross in these majestic, slow-motion encounters that play out over billions of years. When these massive cities collide, the gravitational shockwaves trigger immense bursts of new star formation. Actually, our own Milky Way is on a slow-motion collision course with the Andromeda Galaxy right now.
In a few billion years, these two giant spirals are going to crash and merge, completely transforming their appearance into one giant elliptical galaxy. So gravity is basically constantly demolishing and rebuilding. Let's zoom out for a second, way out, to the absolute largest possible scale, the galaxies themselves. They don't just float randomly out there. They actually form what we call the cosmic web. Individual galactic cities are drawn by gravity into massive clusters, and then these clusters are strung together by enormous filaments stretching across the entire universe. For instance, our own galaxy is part of the staggering Laniakea supercluster, which is this massive structure containing 100,000 galaxies. It is essentially an infinite, brilliantly illuminated intergalactic highway system, with vast empty voids just sitting between the glowing strands of connected cities.
Okay, so to make this abstract, completely mind-boggling scale just a little bit more personal, let's bring it right back down to our own neighborhood. Your specific cosmic address in that massive, sprawling web is the local group. This is our local cluster, just a small collection of galaxies that are gravitationally bound and traveling together through space. And right there, nestled safely inside this local group, is our home city, the Milky Way.
So, you might be wondering, why does all this grand cosmic architecture actually matter to you and me? Well, it matters because of what happens inside the city walls. Inside these immense structures built by gravity, stars are born in beautiful stellar nurseries. Around those stars, planets slowly take shape from the orbiting dust. And across these galaxies, the very ingredients for life are forged in stellar cores and then spread outward. Every single star you see in the night sky belongs to this much larger story. The galaxy isn't just a container, you see. It is the active, churning engine for life itself.
Which leaves us with this final, truly profound thought to consider today. If gravity, this ironically weak force up close, can patiently organize billions of isolated stars into magnificent, highly structured galaxies over billions of years, what other incredible structures might still be waiting to form somewhere out there in the deep universe? I mean, the construction project isn't over. And as you look up at the stars tonight, it is so thrilling to ask, could there be other civilizations standing right now in their own cosmic cities, looking up at their night skies and wondering about us? I really hope this explainer has changed how you view the incredible architecture of our universe. Keep looking up and keep wondering.